This is section 3.2. This is another review section. It's over multiplying radicals and rationalizing the denominator. So when we multiply radicals, again, we're going back to this, our product property of radicals. So the nth root of a times the nth root of b is the nth root of ab. So as long as your power of your root or the index is the same, then you can combine them. All right. Now, it does not apply to addition. You don't combine them for addition. Okay. Only the only time that it would apply for addition is if what you have inside the radicand is the same. So in other words, if this were an apple and this were an apple, you would have two apples. If this is an apple and a banana, you don't combine those, but you could combine that into two apples. Okay. All right, so you've got some examples here, and I went ahead and color coded so that you could see how they did that. So here, when you multiply two radicals, we multiply the numbers together, and then we combine what's inside the 7 and the 14. Okay, they went ahead and here's the first 7. They went ahead and factored the 14 into 7 and 2. So the 7 squared, pull the 7 out, multiply it times the 6, and so on. And so the example shows one without the radical, just like if you were to distribute like normal, when we had polynomials. Well, the same thing holds for radicals. So 4 root 5 times root 5 minus 2, well, you would distribute 4 root 5 times root 5 minus 4 root 5 times 2. So 4 times root 25, and then minus 8 root 5. I don't know why I didn't finish this out. So this would be 20 minus 8 root 5. Square root of 25 is 5 times 4 is 20. So that's where that came from. And then foiling. The same thing holds for foiling. First, outer, inner, last. Simplify everything that you can. Okay. And in this case, there's nothing that we can combine. So you just have this kind of long answer. All right. So let's look at number 1. So number 1, we're going to distribute. So we're going to have 2 root 3 times root 6. Here's the plus sign. And then we have 2 root 3 times 3. I'm going to go ahead and put this 3 in parentheses. Actually, let me put the 6, the square root 6 in parentheses so that you know that came from the inside. Okay, so now we're going to have 2 times the square root of 18 plus 6 times the square root of 3. 18 we can split up into 9 times 2. Here's our 6 root 3. So the 9 comes out as a 3. So 2 times 3 is 6. So that's 6 root 2 plus 6 root 3. Our radicals are not the same. They are different. So I cannot combine that. That's it. That's as far as I can go. Okay. Now let's look at number 2. So we're going to distribute. I should have done this. All right. So now we're going to distribute the cube root of 4. So we have the cube root of 4 times the cube root of 2 minus the cube root of 4 times 3. Okay, so for this last one, there's really nothing to do. I just have to move the 3 to the front, and that's it. But here, since I can combine my radicals together, so this is going to be the cube root of 4 times 2 is 8 minus 3 times the cube root of 4, which I can't break that apart, but the cube root of 8 is 2. And so at least that part got to clean up. Okay. All right. Now, number 3, we FOIL. First, outer, inner, last. So first, that's going to be 8 square root 2 times 3 square root 2 plus the outer is going to be 8 square root 2 times 4 plus, actually, this. Now we're adding all these terms together, and some of these terms might end up becoming negative. Okay, but I'm just going to always add. Okay, so now we have, let's see, first outer. Let's do the inner. Let me do this in yellow. I mean, green. I don't think this is going to come out. This green doesn't turn out very good. So this is minus 7 times 3 square root 2. And then we have the last. And let's see, I guess I'll do this in orange, but kind of is going to look like red again. Okay, so then let's see, first, outer, inner, last. Yeah, so this is going to be plus, and then we have the negative 7 times 4. Okay, and now we're going to clean up our answer. Okay, so once you simplified and cleaned everything up, you should have gotten 20 plus 11 root 2. All right, so now let's go to number 4. We're going to do the exact same thing. I'm not going to color code now because you should know how to FOIL. Okay, so first, this is going to end up giving us a 24 times y squared. Outer, that's a plus 32 square root y. Inner is a minus 21 square root y. And the last is a 28. And if you'll notice, it's very similar. It's identical to what we had in number 3. The only difference is instead of a square root 2, we have a square root y. So 24y plus 11 square root y minus 28. And that's it. That's as far as we can go. Okay. Now, number 5. Again, everything we do with polynomials, we're going to do the same thing. So we have a binomial times a trinomial. So if you want to make a box, we can do that. Or if you want to distribute, you can distribute. Do whichever. Float your boat. So I'm going to go ahead and make the box. Let's see what happens. So we're going to get negative 8 times the square root of 9. This is going to give us the square root of 15, and this is the square root of 6. Then we have positive 8 times the square root of 15. This is going to give us minus the square root of 25 minus the square root of 10. Okay, well, doesn't look like this made things any better. I do see these are like terms. These are going to be able to be simplified. So this would be minus 8 times 3 minus a 5. And then these are going to be plus 9 root 15. And then we have plus the square root of 6 plus the square root of 10. So minus 24 minus 5 plus all of this. So that's minus 29. And then we get all of this that just doesn't simplify. Okay. And that's about it for that one. Okay. All right. Now we have those special products. When you have, remember when we had the conjugates, that turns into a difference of squares. This should be an equal sign. And we have the square of the binomial. Now when you're, well, for the product of the conjugates, this is where you just multiply the first two terms in your binomial and the back two terms in the binomial. So x times x is x squared. Negative times a positive is a negative. So 4 times 4 is 16 times the square root of y squared. So x squared minus 16y. That's what that turns out to be. Okay. Now for number 7, we're going to do the same thing again. It's the first terms multiplied together and the back terms multiplied together. 9 times 9 is 81. Negative times a positive is a negative. So we get 4 times 4 is 16 times the square root of 4. So 81 minus 16 times 2. So that's 32. I don't feel like thinking. So 81 minus 32 is 49. So we get 49 as our answer. Okay. All right. Now for 8 and 9, what I would suggest that you do is go ahead and expand this. Square root of a minus 3 times square root of b times the square root of a minus 3 times the square root of b. And then we FOIL, first, outer, inner, last. So this is going to be the square root of a squared. The outer is going to give us minus the square root of ab. Inner minus 3 times the square root of ab plus 3 times 3 is 9 times the square root of b squared. Okay, so this is a. The two middle terms are going to clean up to be minus 6 times the square root of ab plus 9b. And that's it. Okay. Number 9, we do the same thing. Okay. So we're going to get first would be the square root of 36, outer plus 3 times the square root of 12, inner plus 3 times the square root of 12, and then last plus 9 times the square root of 4. So this is 6. This is going to give us 6 times the square root of 12. And then the square root of 4 is 2. 2 times 9 is 18. So 18 plus 6 is 24. Here's the 6 that's on the outside. The 12 we can break apart as 4 times 3. So we get 24 plus the 4 comes out as a 2. 2 times 6 is 12. And then the 3 stays inside. And that's our answer. Okay. All right. Now, the next thing is we talk about how to rationalize the denominator. And when you rationalize the denominator, the whole point is you don't want the radical in the denominator. And the way that we get rid of that is it totally depends on the power of the root. Okay, so if it's a square root, then you would multiply it by itself. If it's a cube root, then you would have to multiply it. You would have to have 3 sets multiply together. And if it's a 4th root, you would need to have 4 sets. If it's a 5th root, you would need to have 5 sets, and so on and so on and so on. But that can get a little tricky. So the example that they show you, they have the 9th root of x to the 7th. So what do we have to multiply to get x to be by itself? Well, since you have the 9th root, that means every 9 x's, that would come out as 1. So if I have 7, then that means I need 2 more. So that's why that's an x squared. So when you simplify this, it's the 9th root of x to the 9th, and 9 divided by 9 is 1. So that's why the x just turns out to be by itself. Now, when you rationalize, you're basically getting, you're using some of your fraction rules. Okay, so you're multiplying the top and the bottom by some number. So 8 over 15 is equivalent to what over 30? Well, 15 and 30, 15 times 2 is 30. So if I multiply the bottom by 2, I multiply the top by 2. So that would be 16. But when you have something like this, 4 over the square root of 3 equals what over 3? Well, then that's not so obvious. So here's what we do. In order for me to get rid of the square root of 3, I'd have to multiply it by itself, a square root of 3. And whatever I do to the bottom, I have to do to the top. That gives me the square root of 9, which turns out to be 3. And then in the top, you just multiply those together. Okay? So now, on number 10, 7 over the square root of 6. I can't have the radical in the denominator. Okay? So I've got to do something to make that radical disappear. All right, so what I'm going to do is now square root of 6 doesn't simplify. So I'm going to multiply the top and bottom by the square root of 6. So this is going to be 7 root 6 over the square root of 36. So 7 root 6 over, and then the square root of 36 is just 6. This is my answer. And no, you may not reduce these 6's. This 6 is underneath the radical. This one doesn't have a radical with it. You can't, they're not the same term, so you're not able to reduce those. Okay, now, number 11. What we could do, and probably should do, is go ahead and break this apart. Square root of 5 over the square root of 12. The reason why is I recognize that 12 can be split into the square root of 4 times 3, right? So this is going to turn into the square root of 5 over 2 root 3. Now, the radical is the only thing that I'm not allowed to have in the bottom. The 2 is okay. So what I'm going to do is multiply the top and the bottom by the square root of 3. And so this is going to give the square root of 15 over 2 times, well, the square root of 3 times the square root of 3 is the square root of 9, which turns out to be just a 3. So this is the square root of 15 over 6. Now, the part that I would love for you to catch on is notice that when you multiply a radical times itself, square root 3 times square root 3 turns into square root 9, but it's just 3. So a radical times itself, do you see how it just pops out? The 3 just turns out to be. And then we've got the square root of 6 times the square root of 6, which is just root 6. Okay? All right. Number 12 is next. So we're going to simplify this as much as possible. So let's go ahead and split up the top and the bottom. So there's the 25. Now I'm going to go ahead and separate this x to the third into x squared times x. Okay, and the reason why is because I want to pull out any perfect square that we see. So in the top, we have the square root of 6. In the bottom, the 25 comes out as a 5. The square root of x squared is just an x, and then we're left with this square root of x. Now, again, we cannot have a radical in the denominator. So let me copy this and start fresh on this line. All right, so we're going to rationalize the denominator. And so I'm going to multiply the top and the bottom by the square root of x. So in the top, I can combine this into the square root of 6x over, now here's the 5x that I already have. Now the square root of x times the square root of x. This is what I was saying earlier. A radical times itself just pops out the radicand. Radical times itself pops out the radicand. Radical times itself pops out the radicand. So here, square root of x times square root of x is just an x. So now we have the square root of 6x over 5x squared. Okay. Now, this is where it's going to get a little interesting. Notice what we have in the bottom. So we've got a cube root. Okay. So I need sets of 3 for the radical to go away. Okay. So I'm going to multiply the bottom by the cube root of something, which means I have to multiply the top by the cube root of whatever that something is. Now, I need, since I see this 2, I need 2 more 2's because we're dealing with a cube root. So I need 2 more 2's for a 2 to pop out. So 2 squared. I have an a squared, and I need a set of 3. So I need 1 more a to pop out. So I'm going to multiply the top and the bottom by the cube root of 2 squared a. Now, in the bottom, let's just look at this for just a second. So we have the cube root of, well, 2 to the third times a to the third. And then in the top, all I have to do is just combine this, c times the cube root of, well, 2 squared is 4, and then there's the a. Now, in the bottom, remember that for cube roots, you want sets of 3 to pop out. So 3 divided by 3 is 1, which means the 2 is going to come outside. 3 divided by 3 is 1, which means an a comes outside. So that's my answer. C times the cube root of 4a over 2a. Okay. All right. Now, number 14 is already combined. And I'm going to leave it this way because I notice 18 divided by 36 is 1/2. So that's going to clean up nicely. Yes, this is a perfect square. Okay. But I can simplify this entire fraction and make it a little bit nicer. So this would become y over 2x. That's what would be on the inside. Now, since it's the radical of a quotient, I can separate that. And so here, I'm going to multiply the top and the bottom by the square root of 2x. So in the top, we have the square root of 2xy over, now again, just like I said earlier, for square roots, a radical times itself, the radicand pops out. So this is just going to be a 2x that pops out. And that's it. Okay. All right. Now, number 15, we have the fifth root of 2n over the fifth root of m. I'm not even concerned with the numerator. I'm just concerned with the denominator. So I have a fifth root, so I'm looking for sets of 5. Since I have 1m here, I need 4 more. So I need to multiply by the fifth root of m to the fourth. So now in the top, this is going to give me the fifth root of 2m to the fourth times n over the fifth root of m to the fifth. And the fifth root of m to the fifth, 5 divided by 5 is 1, so that just leaves me with an m. And then in the top, we didn't have to change anything. So the fifth root of 2m to the fourth n all over m. Okay. Now, the good thing is you don't have, this doesn't happen often where you have to rationalize the denominator higher than a square root. Okay. So you can at least relax on that one. Okay. So now that was rationalizing one term in the denominator. So now we're going to rationalize a binomial. Now, we're going to use this idea again about the conjugates. Okay. So that's why this is brought up. And that's why this is so important that you understand that when you multiply conjugates, that this is what you get back out, so that you're not doing first, outer, inner, last, but you just know, oh, those are conjugates. So it's first terms multiplied together and then second terms multiplied together. Okay, so here's an example. Here's what they have: 1 over square root 5 minus square root 3. And so the way that we do this is we multiply by the conjugate of the denominator. So the conjugate of a plus b is a minus b, and the conjugate of a minus b is a plus b. So since I have root 5 minus root 3, its conjugate is root 5 plus root 3. So whatever I do to the top, I do to, or bottom, I do to the top, and then I clean everything up, right? So the first thing that I'm going to do is for 16, I'm going to put this in parentheses. Okay. Now the conjugate of 3 minus root 3 is going to be 3 plus root 3. Whatever I do to the bottom, I do to the top. Okay. So now we're going to have, let's go ahead and clean this up. So this is 36 plus 12 root 3 all over, and then first times first, 3 times 3 is 9, minus root 3 times root 3, radical times itself is just the radicand. Okay. Oh, you know what? I was even wondering about this. I should have left it alone. In this case, I should have left it just like this. And you'll see why. So in the bottom, 9 minus 3 is 6. And here's why. Because now I can see, oh, I can reduce this. 6 goes into 12 2 times. So this is just going to give us 2 times 3 plus root 3. Now, I would be okay with this answer. Alex might want you to distribute and get 6 plus 2 root 3. Okay? So you're going to have to be careful whenever you work on your homework. If you have to answer something like this, sorry, this is a review section, but if you have to answer something like this, you want to be careful. All right, number 17, I'm going to wrap my denominator in parentheses. Now, I need the conjugate. So this is 2 root 5 minus 3. Okay. All right, so in the top, let's leave this alone in case we have to reduce. Okay, so in the bottom, first times first, 2 times 2 is 4. Root 5 times root 5 is just 5, minus 3 times 3 is 9. So we get 2 times 2 root 5 minus 3 over 20 minus 9 is 11. And again, I am okay with this answer. Okay. All right, number 18. We're going to multiply the top and bottom by the conjugate. So this is going to be 1 plus root 6. And then in the top, 1 plus root 6. So we get root 3 times 1 plus root 6. And then in the bottom, 1 times 1 is 1, minus 6. Root 6 times root 6 is 6. So now here I am going to go ahead and distribute, because I notice that when I multiply the root 3 times root 6, that's going to give me root 18, and there's a perfect square inside there. Okay. These other examples, I didn't have two radicals in the top to do that. But here I'm going to go ahead and do that. So this is root 3 plus root 18 over negative 5. Okay, root 18 is going to be 2 times 9. So here's root 3 plus the 9 comes out as a 3. The 2 stays inside. And there's our minus 5. So here's your answer. Okay. All right. Number 19. The conjugate is going to be 3 minus 4 root x. Okay. Let's see. So this is going to give us 16 times 3 minus 4 root x all over 3 times 3 is 9 minus, well, 4 times 4 is 16, and then root x times root x is just the 16x. And I really don't see any benefit of doing anything else. I would probably just leave my answer like this. The reason why is I can't combine this because this has an x, this doesn't. And there's nothing that I would be able to simplify the top with. Okay, so I would just leave that one alone. Okay, one more. So we're going to wrap the denominator. Here, I'm actually going to wrap both in parentheses. Anytime you have a binomial, you want to wrap them in parentheses. So the conjugate is going to be root 7 plus 2. So now we're going to have to FOIL. So 2 root 7 first. Outer is going to be a 4. Inner is going to be root 7 times root 7, which is just 7. And then last is going to be 2 root 7 all over root 7 times root 7 is just 7 minus 2 times 2 is 4. All right. So now we have 11 plus 4 root 7 all over 3. And there's nothing else that I can do to simplify it. That's it. Okay. That's how you rationalize the denominator. Now, this is going to come back into play on some of your, when we deal with quadratic equations, you might have to rationalize the denominator. Okay. To clean up your answer. All right, guys, that's it for this section.